This is TechCrunch. So today on TechCrunch's Startup Podcast, we're talking about reactors. One nuclear reactor and the other a fusion reactor startup company. Let's start with Antares Nuclear, which is a nuclear power startup that has raised $470 million to build small reactors for U.S. military bases. The Series C round, which was led by Paradigm and Caffeinated Capital, with participation from Industrious Ventures, Point72 Ventures, and Shine Capital, underscores investors' growing interest in advanced nuclear startups, a trend fueled by an AI data center building boom and demand for new sources of power. The Series C round included $370 million in equity and $100 million in debt. Antares has been developing a small modular reactor, or SMR, capable of producing between 100 kilowatts and 1 megawatt of electricity, enough to power up to 750 homes. Like many other advanced nuclear startups, Antares' reactor uses TRISO fuel, which encapsulates uranium in carbon and ceramic shells. TRISO has been touted for years as a safer alternative to traditional nuclear fuel. The billiard ball-sized spheres of TRISO fuel can be cooled by gases like helium or molten salts. The coating is designed to prevent the fuel from melting in typical high-temperature reactors. Antares' demonstration reactor, the Mark Zero, reached criticality back on June 4th at the Idaho National Laboratory. The company is one of 3 finalists in the Pentagon's Advanced Nuclear Power for Installations program, which will test SMRs on Air Force bases in Colorado and Montana. Antares aims to bring its first electricity-producing reactor online next year, with deployments at U.S. military installations planned for 2028. Investors have been flocking to nuclear power, and fission in particular, as electricity demand surges in response to data center construction and the broader electrification of the economy. Back in April, X Energy raised $1 billion through an IPO, while Radiant Energy, Standard Nuclear, and Last Energy have raised 9-figure rounds each since December. Antares closed its last round, a $96 million Series B, also in December. Altogether, Antares has raised $604 million based on a TechCrunch analysis of PitchBook data. Despite investor excitement, advanced nuclear startups face several hurdles to commercialization, including an immature supply chain in the U.S. and challenges with scaling production. Many SMR startups tout the benefits of mass manufacturing, claiming it will significantly reduce costs. But the benefits of mass manufacturing typically take at least a decade to materialize, and no startup has reached that stage quite yet. The first SMRs, which are expected to enter service in the early 2030s, are unlikely to be cost competitive with most new power plants. Lazard, which analyzes the cost of energy for a variety of technologies, expects new SMRs to cost about $214 per megawatt hour. At that price, they would cost more than all but the most expensive gas turbines. Antares has not disclosed its pricing, but given the realities of the market, it's not surprising that the startup decided to chase contracts for the U.S. military, a famously price-insensitive customer. For hard tech startups, manufacturing is a pretty pricey endeavor. Now, Thea Energy has a leg up, courtesy of a Department of Energy grant. The fusion power startup told TechCrunch on Monday that it has received a $20 million award from ARPA-E to help manufacture its modular high-temperature superconducting, or HTS magnets. HTS magnets are costly, but important components in any magnetic confinement reactor, one of the 2 main ways startups are attempting to harness fusion power for commercial purposes. In magnetic confinement reactors, powerful magnetic fields contain and compress plasma, helping to heat the particles until the fuel can fuse and release large amounts of energy. Thea's reactor is based on a design known as a stellarator. Stellarators look like inner tubes that have been twisted and squeezed in ways that help it confine the plasma more effectively. Most stellarators use magnets that are built to mimic those twists and turns, which makes them expensive to manufacture. To minimize manufacturing costs, Thea uses fewer variants. The 12 large magnets that do the heavy lifting are made from 4 different templates, and the more than 300 smaller magnets used to fine-tune the plasma are all identical. They're arrayed around the periphery of the reactor, similar to how pixels are distributed across a computer display. The small magnets are controlled by software, an arrangement that should allow for more forgiving construction tolerances, which could lower costs. At least that's what Thea says. Thea's among the top-funded fusion power startups, having raised $100 million back in May, on top of a $20 million Series A it raised in 2024. Like many of its peers, Thea has plans to build a commercial-scale fusion power plant in the mid-2040s. That's all for now. For the latest in startup tech news, go to TechCrunch.com.